Hi everyone, my name is Mr. Olonya and I'm here to give you a video session on probability. Actually, this is mathematics for secondary education Tanzania current syllabus, and I'm so happy to be with you to teach you audience on basics of probability. As you can see on the whiteboard here, I've written the title probability. This means this is what I'm going to give you, my audience. So actually, in order to go deeper into understanding this probability, first what you need to have is to know the basics, at least the definition, the concept behind the word probability. Probability is defined in different ways. But for me, here I have defined probability to be the branch of mathematics dealing with prediction of happening or non-happening of events. So actually, this probability is falling under a subject, mathematics, and is focusing on predicting whether event will occur or will not occur. There are so many events in a real life situation where you can predict whether that event will happen or will not happen. What are we going to do is at least to quantify that prediction. It's not predicting just by saying I want you to enable your audience to predict mathematically, to use mathematics to do prediction whether event will occur or will not occur. In other words, you can define probability as the measure of chance for an event to occur or not occur. It's a measure of chance. In real life or in a common way, we are always used to say that maybe a certain event is going to happen by 50% chance, by 20% chance, or I'm sure by 20% chance, or by 100% chance. That means it is just a prediction or an approximate chance for which an event will occur or will not occur. With these two definitions, we are going to deal with this at least to understand more how can you predict and under what aspects of events are we going to use to make prediction of events. Not every event we can try to predict, but some of them we'll take them as case studies in order to understand how to make prediction. Okay, so what comes here is an example of situations or examples of situation, I can say situation, where you can predict or we can see whether the prediction will apply or will not apply. Let's check examples. Okay, so here we check examples of situations from which you can predict the results. In everyday life situation, there are so many situations, there are so many kind of situation, I can say, where you can predict results or the outcome. Now, examples, check here. The football match results. Suppose there is a match between Simba Football Club and Yanga Football Club playing the match. One could predict either the match will end up in a win for one team, lose for one team, or draw for both teams. So these are common prediction always people are making when it comes to football match results. And again, tossing a coin, one might predict that the coin will end up head or the coin will end up tail. Why? Because these are the two possible outcomes from a coin as a result. Another situation or another kind of prediction you can make is from giving base results. Giving base result, one might predict that the boy is going to be born or a girl is going to be born. So one might say, oh, yeah, it's going to come a dead boy or dead girl. It's also possible to predict that kind of result from a mom or a pregnant mom who is about to give birth. So these are three sample of situations, but there are so many all over the world, from one tradition to another, where you can predict the result. Alright, now, so with probability, what we need to cover next is probability experiment. It's very important when you discuss probability also to understand probability experiment. You know why? So wait and see. But before that, what is probability experiment? We define this to be is an experiment. It's an experiment through which an experiment can be done. It's an experiment through which prediction can be done. We are always predicting from an experiment. That is the fact you need to take. Because the experiment is always subjected to giving results, so those results from an experiment is the one we are predicting whether they will occur or will not occur. So probability experiment is very important because you cannot predict from anything out of nothing. We are predicting an event to occur from an experiment. And that kind of experiment through which you can predict, we call it probability experiment. Examples of probability experiments. Examples. It might be tossing coin. It might be tossing coin. Probability experiment might be rolling a die. You can roll a die, and it might be giving birth. Giving birth. Again, you can predict from random selection. You can also predict from random selection, and you can predict from playing card. And so many. And so on. So there are many examples of probability experiment through which you can predict. And here are a few of them. So tossing a coin, you can predict the result. Rolling a die, giving birth, we have seen this. Random selection, playing a card, football match, or any kind of event through which outcomes are there. You can predict one of them or two outcomes, whether they will occur or will not occur. So probability experiment is very crucial when it comes to probability. Next is sample space set. So another important aspect of probability is sample space set, and this one we define to be the set of all possible outcomes of a given probability experiment. So sample space set, actually this is a set collection of all possible, this is important, all possible outcomes of a given experiment. We check an example. For example, A, tossing coin. An experiment involving tossing coin. How many possible outcomes are there? There are two. The possible outcome is that when you toss coin, the outcome might be showing a head or showing a tail. So sample space set denoted by S is supposed to be a set of head denoted by H or tail denoted by T. So this is the sample space set coming out of an experiment involving tossing coin. Another example. The second one is an experiment involving rolling a die. Actually, what is a die? A die is hexahedral shape or hexahedral three-dimensional shape, which is always numbered from 1 up to 6. Hexahedral shape. So I think you have ever seen this kind of shape, which is always used in prediction or in gambling sites, gambling crew. They are using this kind of shape in order to make prediction. So this is called die, and is always numbered from 1 up to 6, either by actual numbers 1, 2, 3 up to 6, or by dots. So dot number 1. Only one dot represents number 1. 2 dots, 2 numbers. 3 dots, 3 numbers. And because this shape is having 6 faces, so we expect to have a total of 6 numbers from 1 up to 6. So when you roll a die, you might end up with showing number 1 or number 2, number 3 or number 6. For example, this die here, the showing up is number 2 because of 2 dots. We are using the upper face to observe the result. The upper face, not this face, not this face, not this one, the upper one. So the upper face is where we observe the result. So for this case, this die is showing number 2. But when you roll it so many times and leave it to settle, you might find that it shows number 3. So from this die, sample space set is given as a set of number 1, number 2, number 3, number 4, number 5, and number 6. So whenever anybody is trying to predict what will happen after rolling a die, these are the possibilities. These numbers. And one of them might show up. We don't expect this die to show number 7 because it is not there. We don't expect this die to show number 10 because it is not there. So it is always numbered from 1 up to 6. Another example of sample space set coming out of probability experiment. So giving birth. Now if the experiment is involving giving birth, one might predict the possible outcomes, one of the possible outcomes. So what we want here is a set of all possible outcomes. That set of all possible outcomes from probability experiment is what we need, and it is called sample space set, and it is always denoted by letter S as capital letter. So giving best possible outcomes, sample space set is either resulting in baby boy or baby girl. So here we are focusing on this sample space in terms of sex. One might think that baby will be alive or will die. I'm not going to focus on that aspect. I'm focusing on sex of the child to be born. So it might be a baby boy or a baby girl. If it is about the life, so you can say that a baby will die or will live. Here my interest is the sex. So sample space set is involving outcomes baby boy and baby girl. So these are just few examples of sample space set from few examples on probability experiment. So after sample space set, we are moving on with this topic at the point where we discuss event set. This is very important to understanding or to defining probability mathematically. And this event set is defined. So the definition is defined to be a set of all outcomes is a set of all outcomes which happened or which showed up from probability experiment. So event set denoted by E is described to be a set of all outcomes which happened or showed up from probability experiment. One thing which is very important to know is that event set is a subset of sample space set. This is very important to know that event set is a subset of sample space set. So it is always contained in this set. So we consider this set to be universal. We consider this set to be universal set. That means all members of event sets are coming out of sample space set. All members of event set are coming out of sample space set. In other words, is that any result will show up after the experiment must come out of all possible outcomes from that kind of an experiment. So that is very important. It's not that this event set is coming out of nowhere. No, it's coming out of sample space set. So let's check an examples, few examples of event set. audience. Suppose, so if after tossing a coin, a head appeared. Let's say after tossing a coin, then a head showed up or appeared. So what we can conclude is that from all possible outcomes, head and tail, then head showed up, while tail did not show up. Head appeared, while tail did not appear. So this head, because it appeared, we describe this to be event. We describe this outcome to be contained in the event set, because we say it is all outcomes which happened or which showed up from probability experiment. Now, so we say that event set equals to set of head. I am just writing a single head here by assumption that we tossed coin only once. But if we tossed coin twice and the head appeared twice, so we could write head equals to event equals to head and then head. So two head there. But because our example is basing on tossing a coin once, so event set is going to be head. Head showed up while tail did not show up. Do not describe tail to be event by this time. We are describing head to be event, because event should be containing outcomes which showed up, which appeared. Please bear in mind that one, that event is containing outcome which appeared after the experiment has been done. Another example from A, let's check another example. So again, let's say after rolling a die, even numbers appear. So event set will be collection of all even numbers, because it is said or it is assumed that even numbers appear. So event set will be collection of all even numbers. Why? Because they appeared after the experiment has been done. So event set should be a set of number 2, 4, and 6. Why are we taking 2, 4, and 6? Remember, a die, all possible outcomes from the die is number 1, 2, 3, up to 6. So we are just picking even numbers from this listing, because those even numbers have been said to be the outcomes which appeared from this assumption part B. So this will be event set in case even number showed up. We can extend the idea that if let's say odd numbers appear, we can extend the idea that if odd numbers appear, what will be the event set here? So you just have to pick odd numbers from all possible outcomes, and this will change, and it will be odd numbers from 1 up to 6 is number 1, number 3, and number 5. So the event set now will change. So event set is changing depending on which outcome appeared and which outcome did not appeared. We are focusing on those outcomes which appeared, which showed up after the experiment has been done. Wow, we are continuing to deal with this probability, and I hope audience you're understanding a lot there. We're sitting watching me teaching to you. Thank you. Now is probability of an event, and we denote this probability of an event to be P of E. So this is same as writing probability of an event. So even if you want to read, you say probability of E, and this E is a short or simple form of writing the word event. Now, so this probability of an event is defined to be the ratio. Of number of elements in the event set to the number of elements in the sample space set. So there are two things here you need that will define probability. First is number of elements in the event set, and another one is number of elements in the sample space set. If you divide the number of elements from event set to that of sample space set, the overall outcome is the ratio called probability of an event. So here now we describe probability of an event, or we measure probability of an event mathematically. We are predicting mathematically by taking the ratio of number of events over number of elements in the sample space set. But again, in another way, you can define probability of an event with this definition at the bottom. That again can be described to be a ratio of number of times. Be careful here. The number of times. It is very different compared to the first definition. Here it was number of elements in the event set, but this time is number of times an event has occurred. So event, if it occurs 12 times, if it occurs 3 times, 6 times, 100 times, we take the ratio of number of times event has occurred to the number of trials of an experiment. In real life situation, you can make a lot of trials, so many trials to achieve something. So the chance of something to happen is that we take how many times the event has occurred, or the success event has occurred, to number of trials. For example, you attempted a particular question 12 times, but lucky enough you got it correct 3 times. That means we take 3 divided by number of trials. So in that case you'll have probability, but we'll check this later on. Do not worry, audience. We'll check this one by example. You have to focus on these 2 definitions, and we are going to start from here to predict mathematically. Now this is just a statement by words, but we can describe this one using symbols and written in terms of formula. Let's check how we do. So actually, probability of an event is mathematically written. It's mathematically written as probability of an event equals to number of elements in the event set divided by number of elements in the sample space set. So this is the definition, a mathematical definition of probability. Because we have been told that it is a ratio of number of elements. So what you need to do? You have to take the ratio. You have to take the ratio actually of number of elements in the event set to the number of elements in the sample space set. So this is the formula that is always used when predicting outcomes of probability experiment. In order for this formula to be true, because this probability is given in terms of ratio, so in order for this formula to be always correct and true, we have to provide a restriction that number of sample space should not be 0. And actually it makes sense, because when it happens that the number of sample space is equal to 0, the fraction will be undefined, and automatically probability of an event will also be undefined. So in order for probability of an event to be always defined, calculated, solved, this restriction should apply. Here we can define the symbols used, that this notation is meaning probability of an event, and n of e represent number of elements in event set. And this represents number of elements in sample space set. Good. So this is the interpretation of the symbols used. You need to understand this one in order to familiarize with the formula as quickly as possible, and also to be comfortable working with this formula in solving different kind of questions when it comes to predicting results from probability experiment. Now we can check cases. We can check some of the facts coming from this formula. And check some of the facts. Pay attention. Check this. This formula, there are three possibilities. Two possibilities. There are only two possibilities which will occur in this form. So I can say cases. There are cases here to start. First is if the number of elements in the event sets equals to 0. When it happens that number of elements in the event set equals to 0, this means that the set E was an empty set. So if you count number of elements from an empty set, nothing, 0. So number of elements of an event, if it happens that equals to 0, what will happen is the formula we can try to reduce that probability of an event will be equals to, this one is 0 over number of sample space, and this will be 0. Again, another case, if it happens that number of event set equals to number of sample space, we are just trying to imagine. When this situation happens, that number of elements existing in the event set match or equal to number of elements existing in the sample space set. What will happen with the formula? So this will be probability of an event. We can substitute now. Instead of writing number of event, number of E, so we'll plug to be number of sample space, because they are equal. So this formula will be, can be written to be, this one should be number of sample space divided by number of sample space after substitution. So if you simplify this one, you get 1. Audience, these are only 2 possibilities that will exist when it comes to probability. These are only 2 possibilities that exist when it comes to probability. And from this we can start something. That probability of an event, the smallest number is 0, and the probability of an experiment, the highest number is 1. The highest number is 1 and the smallest number is 0. So now we can provide a restriction of the value of probability. Not every digit or every number will be a measure of prediction, no. But the mathematical value of probability is limited in a particular range. Which I'm going to give you now. So here we can say now, probability of an experiment can never go beyond 1. What does it mean? It can never go beyond. So we say probability of an event is always less than 1 or equals to 1. In real life situation, the measure of probability can never go beyond 1. So it is 1 or below it. But if you go below 1, from 1 and below, also we find that we can never go below 0. So we are restricting the probability of an event into this range. So whenever you are about to make calculation of finding probability of an event, make sure you understand that the value is always restricted into this range. So simple, what we mean that the value is existing between 0 and 1. Between 0 and 1 inclusively. This is a simple meaning. Some students might find it hard to understand this restriction, but what I'm saying is that the probability of an event is existing between number 0 up to number 1 inclusively, and values outside of this limit is not acceptable. Okay, thank you. Okay, another thing to note, which is very important to understand, is that the value of probability of an event can be expressed as a fraction. The probability of an event can be expressed as a fraction, can be expressed as a decimal, or can be expressed as percentage. So there's no problem. You can find probabilities given in terms of fraction, no problem. It can be given in terms of decimal and also in terms of percentage, no problem. And this is very simple thing to do when it comes to converting fraction to decimal, or decimal to percentage, or fraction directly to percentage. Something that you, my audience, you're able to do it. So we expect to do some worked examples to get familiar with how we can work with this formula for finding probability of an event. Okay, wait and see. Wow, now after so much talking, now let's do a couple of practical examples in order to familiarize with making prediction. So here, as you can see, what the examples, and I'm going to go with example number 1 involving tossing a coin. Now the question says, a coin is tossed once. A a coin was tossed once. So you're asked to find the probability that a tail will occur. Find the probability that a tail will occur. At what chance that you'll get a tail after tossing a coin once? At what chance? And that chance we need to be quantified. We need to be expressed in terms of numbers. So that is what is needed, that you measure the chance in terms of numbers. Not just saying that a coin will land or coin will occur by 50% chance. How do you know? So you have to make a calculation based on the formula, quantify it, and that is what we want. So solution. Now, in order to answer this kind of questions, in order to answer the question, remember the definition. Recall the form. Recall the formula that probability of an event is equal to number of events divided by number of sample space. With this formula, what we need to have in order to find the probability are only two things. One is number of elements in the event set, and again another is number of elements in the sample space set. But you can never find the number of elements in the event set while you don't know what is event set. Also, you can never find the number of elements in the sample space set while you don't know what is that sample space set. So the first target is to find what is event set and what is sample space set. Now sample space set, because this is a coin, how many possible outcomes from a coin? Remember, 2. It is either the coin shows head or tail. So this probability experiment of tossing coin, possible outcomes is head or tail. And how many elements in this set? How many elements? You can count. It is one element and another element. So number of elements in the sample space set equals to 2. You see? And again, we need to know what is the event set. So here, let E to represent. Let E to represent event that tail will occur. Assume the letter E is representing that event that tail will occur. So in that sense, the event set E will be a set of what? So because it has been said from the question that the happening event is tail, so tail will happen, of course. Why do we choose T here? Because it has been said that tail will happen, tail will occur, and we are listing outcomes in the event set, those outcomes which will occur, and the question describes it clearly that tail will occur. So tail will be contained in the event set. And because it is just a tail, we cannot put head here because it is not saying that head will occur. It is saying tail will occur. So event set will contain only tail. And if you count number of elements, you get only one element. So with these two values, these are what are needed in order for you to find probability. So you take these values and you plug into the formula, you kill it. Okay, so now, so say probability of an event is given to be number of elements in the event set over number of elements in the sample space set. So number of elements in the event will go to 1, and number of elements in the sample space set, this one, given to be 2. So you plug there 2. So this is now the probability that tail will occur. This fraction can be converted into percentage, and you will find the probability to be written as 0.5. If you convert into decimal becomes 0.5. But again, it's also possible you can leave your answer in terms of decimals. After converting a half into decimal by multiplying with 100%, answer can be written to be 50%. After here, now you can understand what I mean when I say measure of chance. So the chance that tail will occur after tossing coin once, that chance is 50% chance. But you can describe in terms of decimal. That's no problem. 0.5 chance or half a chance in terms of fraction. So this is how we solve this example number 1 involving tossing coin. Let's check example number 2. Alright, so example number 2 with this study of probability. Let's check with this example number 2 what is all about. It is about a die. A die was rolled once. So a die was rolled once. And you asked to find the probability that even number will appear. Or it says the chance that even number will appear. Measure of chance is probability. So here the question is demanding you to find probability. So again, because now you know the basics, first of all you have to identify the sample space set. The sample space set when a die is rolled. I think you remember from probability experiment. This probability experiment of rolling a die, possible outcomes are number 1 up to 6. So it's 1, 2, 3, 4, 5, 6. Now count how many elements inside this set. If you count how many elements, you find there are 6. So again, let E to represent this event that even number will appear. What is going to happen? What is predicted to happen is even numbers. So let E to be event that even numbers appear. So set E now is going to contain all even numbers coming out of sample space set. This is like universal set. So all members of E should come out of sample space set. So you have to pick all even numbers from S. It's supposed to be 2, 4, and 6. If you count the members inside, you get 3. So now the probability of an event being defined to be number of elements divided by number of elements in the sample space set. This is going to be equal to what? You take the value, this one is 3, number of elements in the sample space set here is 6. Simplify this fraction, you get a half. So probability of an event equals to a half. And again, the chance that even number will occur is half the chance, or 50% chance. Moving on to example number 3. Now, a coin was tossed 100 times. And if it happened that head appeared 30 times, out of those tosses, out of those 100 tosses, head appeared 30 times, you are asked to find the probability that head appeared, and again the probability that tail appeared. So here again, as usual, what is needed is two factors. One of the factor is number of sample space. Number of sample space. And for this kind of question, it is practically impossible to identify the sample space set, but it is easy to know the number of elements in that sample space set. Why? Because it is given. The experiment was involving tossing coin 100 times. So possible outcomes will also be 100 elements. So we say directly that number of sample space equals to 100, but number of heads, this H is representing head. I'm trying to answer part A of the question. So the number of head appeared, it is given to be 30 times. 30 times, 30 heads. If head showed 30 times, that means head appeared 30 in total. So we say this number of head is 30. And this automatically means the number of tail to be the remaining tosses. If 30 tosses showed head, the remaining tosses out of 100 now will be for tail. So we expect to be 100 minus 30, which will get 70. So with this part A, because you are asked to find the probability that head appeared, this is denoted to be P of H. P of H, probability of an event heading. When head is an event now, so we can write P of H, probability of head to occur. So if you extend the concept or you extend the definition of probability in terms of formula, this will be the number of heads divided by the number of sample space. Filling the values, the number of head is 30 and number of sample space is 100 tosses. Simplifying this fraction, you get the probability of head to be 3 out of 10. That's it. And part B, so we take the probability that tail will appear. So you have to take the number of tails appeared per total trials, per total tosses. So this will be probability of tail to appear will be equal to number of tails divided by number of sample space or number of trials in the experiment that has been done. So filling the values again, we get this one, 70 as number of tails, so it will be 70 divided by number of sample space is the same because the experiment remains the same. So probability that tail will appear, if we simplify this fraction, you get 7 out of 10. That's it with this example number 3. So I think this session is moving on amazingly, and I'm so glad to continue with example number 4, dealing with probability of an event. Here now we have probability experiment which is random selection. So this question is based on random selection. Now here there is a box containing 5 red balls and 3 blue balls. But one ball is picked at random. One ball is picked at random without prior knowledge what is being picked. That's what is meant. Now, so one ball is picked at random. What is the chance that the ball picked will be of blue color? What is the chance that the ball picked at random will be of blue color? Remember, in the box there are a total of 8 balls, 5 and 3, a total of 8 balls, 5 red balls and 3 blue balls. So of course every ball will have its own chance of being picked, and here we are asking the chance that the ball picked will be of blue color. So it is blue color versus red color, blue color versus red color balls. Now, so for this example, sample space set is going to represent a set of all balls, and remember there are 5 balls red and 3 balls blue. So set of all balls available. And if you count how many balls in the sample space set, number of sample space set contain total of 5 plus 3, which is equal to 8 balls. 8 balls. And the question is asking to find the probability that the ball will be of blue color. Now you have to ask yourself the event that the balls are blue. The event that balls are blue will contain how many balls? And actually, the event will pick the values from the possible outcomes, which is sample space set. So the number of members which are supposed to be contained in the event sets are coming out of sample space set, and because this event is showing or is indicating the outcomes which will happen, and outcomes which will happen have been said by the questionnaire that the balls should be of blue colors. So you have to pick blue balls from sample space set, and these balls are supposed to be 3 blue balls, because one of the blue ball might be picked. There are 3 balls which are blue in color. One of the blue balls out of 3, every ball is having the chance of being picked. So we have to find that chance that a blue ball will be picked. Here now you count the number of members in the event set. You have only 3 balls. So this value and this value is enough for you to find the probability of picking a blue ball at random. So by definition, probability of an event is given to be number of elements, the event set divided by number of elements in the sample space set. Here you have to plug the values given or calculated. So number of elements is 3 from event set, and number of elements from the sample space set is 8. So now that's it. So this is the value of probability, or the chance that a blue ball will be picked. That's no problem. Students. You can even find the chance that red ball will be picked. So it's simple. It's supposed to be 5 ball out of 8. Simple as that. So this will be the probability of drawing a red ball out of 8 balls which have been mixed, 5 red balls and 3 blue balls. But the target of the question is to find the chance that ball picked at random is of blue color. This one is just about extending the idea. Thank you for listening me. Thank you for your time and attention. I am very glad to be with you, and I hope you follow me, you subscribe my YouTube channel to get in touch with me. Yep, that's what I can say. Bye.